Okay, so 22. Use the graph shown below to answer the following question. So we have two graphs. We got this velocity versus time graph, and then we got this velocity versus time graph. A, what kind of motion does graph A represent? So how would you describe the motion of graph A, this first graph on the left? Constant velocity. Right? The velocity is not changing. Hey, and what's another name for constant velocity? Zero acceleration. Notice, what's the slope of this line right here? Zero. If something moves with a constant velocity, that means it's not going faster and it's not going slower. Zero acceleration. Okay, B, what does the area under the curve for graph A represent? So the area under this graph, what is it? The displacement. Okay. C, what kind of motion does graph B represent? Well, what's happening to the velocity? Well, actually, you know what? This is not a constant acceleration. A constant acceleration would be, if you have velocity time, this would be a constant acceleration, like that. This, you know what? I think this is too tricky for regular physics. This is an increasing acceleration, right? The slope is getting bigger, 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 bigger. But you know what you could say? I mean, basically the idea is that it's accelerating. It's not a constant acceleration, but it is an acceleration. How do we know that this is an acceleration? Because the velocity is getting what? Bigger. The velocity is getting bigger. Although it would not be a constant acceleration. This would be a constant acceleration. All right, D, what does the area under the curve for B show us? What's the area under the curve?
The displacement of object.
It's the displacement. It's the displacement. Okay. Okay.